Hey everybody, welcome to the your final synchronous class for the NERRS UAS data analysis and training class. Hopefully you guys can hear me okay. I'm actually streaming to you guys down from or out from the Marine Lab, and I think Justin's been actually working from here as well. But normally I've been beaming into you guys from Duke's main campus, so it's nice to be back down here at the coast. I'm excited to be able to join you guys. So surprised. I'm not sure if Justin told you he wasn't going to make it tonight. And you guys instead got stuck with me. And hopefully that's gonna be okay for y'all. Gonna have some fun tonight. I wanna sort of take some time out and uh, ask you for some feedback on some things, and then we're gonna talk a little bit more about some advanced sampling things, and kind of end on a note on about sort of next steps and maybe kind of get away from some of the ideas about remote sensing as the only way you can think about using drones, and talk a little bit more about some advanced things in that area, but also beyond it. Okay, so let me see if I can get my PowerPoint stuff going. Hopefully that's showing up for y'all, and so yeah, I hope that you guys have had a good time in the class. I know that it's a kind of set put together to try and kind of hit the stuff that I think you guys are interested in. But I'm pretty keen on hearing from you about sort of some of the more sort of maybe some of the nuanced feedback that you might have, maybe some things that you missed or that you wanted us to cover, stuff like that. So, but my hope is that you guys are well on your way and even better at doing what's pictured on the screen here, right? Getting out in those coastal areas and using these tools to be able to answer the questions that you need to answer. All right, so yeah, first things first, I want to talk about feedback, and then I want to talk a little bit about advanced sampling. I know you guys have talked a little bit about LiDAR, and we might talk a little bit about that earlier in the class. I want to talk a little bit more about new avenues in the LiDAR world and how we're going to start using LiDAR for different things. And then I also want to talk about physical sampling, right? So you probably haven't talked all that much in class about how we can use drones to actually collect physical samples. And in the course material, there's probably some stuff in there about the snot bot being able to collect whale snot. But there are lots of other things that we can do with drones now to be able to think about using them as tools to expand how we, uh, you know, think about using these tools, and do things that, again, these things were not possible, even 10 years ago. So, and in that case, we're going to talk about doing things like water sampling, and I'll give you an example of a commercial system that you can get that would allow you to do that, and talk a little bit about some of the nuances associated with that and why you would want to be able to do it. And then also thinking about vegetation sampling with some new tools that are emerging that are pretty cool. And I have a couple of examples that I want to show you. And then I want to finalize the tonight and just talk briefly about sort of other small robotic platforms and give you a sense of how you might be able to use those sort of in conjunction with aerial drones that you're working with, to build a more robust and holistic picture of a particular location that you're interested in studying. Okay, so that is our roadmap for tonight. And I will maybe pause right now and see if you have any questions just about our plan for the evening. All right, let's move on. So hang on here. I think I'm got some stuff out of order. Let me just do a quick switch back here. Sorry, guys, that's out of order. Okay, so if you haven't already, I think you'll get a link to a course questionnaire where we're going to ask you for some feedback. And it would be wonderful if you guys would fill that out and give us, some, we really want to be able to make this better. And the truth is, we can't improve it if we don't get details back from you all. And so that's why I wanted to actually set aside maybe 10 or 15 minutes tonight and really try and pull out some feedback from you all. In particular, I'm really interested in hearing from you about what parts of the class you actually really enjoyed. What were the things that were valuable for you? What were the things that really meshed with what you need in terms of the work that you're doing? Maybe that's present work, or maybe that's future things. And yeah, what were the things that you think we missed, right? Where are the areas where we should add more stuff in, so that we can target, folks that like you, right, that are thinking about using this tool more frequently in their work that they do. So I'm going to open it up, and I may actually see if I can call out people to see if we can dredge some information out. But does anybody want to kick us off with some quick thoughts on what might be what did you really like about the course, and what did you dislike? Anybody have any strong opinions about that? And feel free to drop it in the chat, or unmute and raise your voice. That's awesome. Thank you so much for the Twine game stuff. The when we first embarked upon this, it was actually by chance that we ended up really working on gamification in the course, and it was because we had a really amazing colleague in Duke Learning Innovation named Hannah Rogers, who actually did her PhD on gamification in teaching, and so she was able to like invoke this Twine tool for us and be able to actually really kind of game those things out. If you've ever seen what those look like, it's actually a pretty simple system. It's all like really simple web-based type stuff, but these kind of web of like possible futures that you create with those things can get pretty complicated, right? There's so many different ways that things can go, and so it was really wonderful to be able to have that support. One question that I might have as a follow-up on that is, one of the things that we tried to do is kind of have the mission simple at first and then think about building on that, right? So initially it's kind of just about platform choice. And then secondly, it's more about, sort of the data collected and sensor type and things like that. And then finally, you end up working through the best practices part of, social and environmental justice issues or governance issues or permitting and ethics. And I guess the follow up for me is that, do you think that progression worked? Is that a helpful way to do it? Because you know the go ahead, please. That's great. Does anybody else have any thoughts on the Twine game stuff? Um, Anything that they found helpful or not helpful? Okay, that's great. Yeah. Yeah, I think that one of the things that's always hard is to try and judge sort of where people are starting from, and often there's some variability in that. Some people in the class, maybe using drones for things already. Some people may have very little experience, and so that's super helpful to hear that. Anyone else have any comments on that? Right. Okay, that's great. Yeah, yeah, I think we could definitely build in some of that, gamify some of that, like those experiences as well. Steve, I think you were going to jump in there. Did you have anything? Yeah, that would. Okay, yeah, that's really good to know. I think this is one of those. I think the timing part is challenging, and I think the thing that I think we're picking up on is if we were, yeah, to do this earlier, before the weather started to get nice out and people started thinking about having to actually get in the field and do things at the beginning of the field season, that would be beneficial. And that's something that we can work on with Justin, right? To think about timing. Um, but I think we can definitely work around that. Yeah. Okay, that's great. Thank you. Yeah, thank you for that feedback. Like it is kind of like it's interesting because some people come in and they're already using that and they're looking for some analytical skill up. Some people have come in and they have no idea. And so the course starts out relatively basic, right? We take everybody back to kind of like first principles of flying and the basic fundamentals of remote sensing. um, and I think that was kind of my biggest sort of question for you all about content. Was the first part of the course targeted at the right level, or was it too fundamental? Like, was that all just boring review for you all? Because that would be really helpful for us because if that stuff is something that's really just, like a not needed recap, then that would allow us to do maybe a few other things that might be more valuable to you. So does anybody have an opinion on sort of that first part of the course and the level that we were hitting it at? Okay. Awesome. Thanks. Anybody else have an idea on that or a thought? Okay. Steve, did you have anything to add? Awesome. Okay, well that's really good to know. Does anybody have like a an idea about, was there something that you thought you were going to get but you didn't? Was there something that you were kind of hoping for and then at the end of it you're like, "Oh, I guess we just not going to cover that." Is there anything like that that was in there? Okay. Okay. That's awesome. Becca, did you have something? Okay. That's great. That's really great. I know that like one of the things that has been kind of prominent in discussions is this sort of geopolitics that are associated with Chinese drones and programs having to switch gears and equipment, confusion and those kinds of things. And I wondered if, if that was something that you guys would that be something that would be helpful for us to kind of talk about in the course? Think about, because we give you some sort of like, rails to think about, what kind of equipment to use, but we don't really talk about the sort of emerging geopolitical issues that are associated with using some of the best equipment out there. And I don't know if that's something that you guys are struggling with, and if it would be helpful for us to have some kind of guide for that. Yeah. Okay, that's good to know because we can definitely help with some of that for sure. That's great. Yeah. Yeah, it's funny like when we're thinking about developing materials for courses, we often think about like stuff that would be evergreen, right? Like stuff that is, 5 years down the road is going to be essentially the same. And then there are parts of this, like you said, that are moving so quickly that it will be challenging to try and keep up. Like I think one of the things that we didn't talk very much about is the remote ID requirements that are just new this year and those kinds of things, right? So people that have older drones, are going to struggle now to deal with some of those things. And I think for us to be able to kind of understand which topics I think would be helpful for people. So, but yeah, this is a problem with with lots of courses, right? As sometimes things, and especially in the environmental sciences, things move so quickly that it can be challenging to keep up for sure. All right. Does anybody have any other just sort of feedback or uh, absolutely, Suzanne? Yeah, 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 yeah. For the lab stuff, I mean, you clearly, like you said, it's in the can, and it's kind of targeted at being, you know, an exercise that that you can most the people can mostly work through. There are always challenges, and as you guys know, that when you work with ARC products, Esri products, there's like 14 different ways that you can do many things, and sometimes you get errors, and it doesn't even explain why. And works one way, it doesn't work the other way, and so there is a pretty large time commitment in getting those things sort of set up, and to be honest, like that really is all kudos to Justin Ridge, right? Justin, like he went to the mat figuring out how to get those things into the right form, and so he's it is a huge amount of work. We pivoted to having to use virtual machines because so many people have restrictions, on computers for work and everything, and that seemed like the easiest way to get around having people have to install software on their home computers or struggle through those things. And so, and I know it's kind of frustrating sometimes to figure out how to use the virtual machines, but they are wonderful, right, for overcoming some of the restrictions that folks that work for federal and state agencies are now running into when it comes to cybersecurity. Any other comments? I think we got like some really great feedback. Timing seems like something that's really important for you guys, and thinking about finding a time earlier in the season when you're not spinning up like mad to get out in the field to do the things you need to do. Um, I think we'll continue to work on the material, the twine games, and things like that. Um, yeah, and maybe try and expand some of those things out to capture some of the things that you're talking about, right? Post field work, what are the next steps? Those kinds of things. I would really like to work on that in the data management side of the things, because I feel like that's one of the most sort of important areas that gets missed when people start, is even something as simple as having a really robust file naming scheme. And 5 years down the road and you don't have that, and you're like looking back like 5 years ago, what did we do? We were here, and trying to find things, and all of those. I think it would be fun to have that as a twine game as well. That would be super cool. I know, it's incredible. And it's really funny. I get emails from our IT people like every 6 months, where they come and they say like, okay, your lab is using like 60% of the disk space for the entire school. You guys need to like find a place to store your stuff and give some disk space back to the rest of the faculty that actually are supposed to be using this stuff. And yeah, I think, the when we see what happens with with satellite-based remote sensing, they have these DACs, right? They have NASA data systems that allow us, to be able to download stuff and store it and serve it and everything. And I think we really need that for drone data, right? Like, we need an open access drone DAC that could take all that stuff and ingest it, and really like save it, right, for the future. And there's just nothing like that out there. There is one of our colleagues, Karen Joyce in Australia, created a system called GeoNator, that is designed to try and be an open access like drone data repository. And so there are some of these options are starting to emerge, but thinking about sustainability and long-term access, and things like that, it's hard to um, it's hard to get around this problem of saving all this stuff and making it available. And on top of that, like, it's still not even clear for people like what to save. Like, do we just save just the raw data, or do we save some of the derived products? Both. Um, those questions are still out there, and I'm hoping that as we move forward, we can get you guys involved in a community of practice that focuses in on some of those data sharing parts. We're trying to get a proposal together for a research coordination network that would help us deal with, like, how would you scope and define what that archive would look like, and then figure out a way to fund it. But data, yeah, it's killer. I do, yeah. Yeah, yeah, sharing them, and even like often, when you share someone like a geotiff, right, of a particular orthomosaic, some people just don't have, like, the people that you might want to share it with just don't have the skill set to be able to load that into a piece of software to even view it, right? And so those cloud enabled visualization systems are great. So Drone Deploy is one. Pix4D actually has a cloud based version that allows you to upload your, or process your data in the cloud, and then share out both, like, 2D orthomosaics and also 3D point clouds. And it's not super expensive, um, but it's another kind of tool like that, thinking about what are the best sort of, um, yeah, cloud-based tools to be able to do that kind of work. Clearly, working in remote places, cloud-based tools are a drag, but in places, when you're back in civilization and you want to share those things out, they're ultimately really powerful. Um, yeah, so if you haven't seen, Pix4D Cloud is one other option. And if you do use Pix4D as your workflow, it actually has some kind of seamless capabilities with the desktop apps. Yeah, that's a great idea. I feel like it just allows you to, yeah, to kind of get over a lot of the variability that's associated with individual people's situations and everything, and have a yeah, like a shared. And now you can actually buy, if you buy like a pretty decent, gaming computer, and you can put some hypervisor software on there, and you can run a couple virtual machines off of it, um, if you have good IT support. Or there's so many online resources like that that you guys could spin up to be able to do it. So it's a great idea. I'm surprised more agencies don't do those kinds of things. Um, it's so much easier to manage. You're not managing, like, hardware that's going to very quickly become obsolete. There's a lot of advantages for sure. Mm. Oh yeah, Digital Coast. That's right. John, was someone else jumping in there? I can't remember. Okay. Yeah, that's great. I love it. It is kind of challenging. We have had trouble when we first tried to do it. The virtual machine system here didn't support 3D stuff, so you couldn't look at the point cloud in Pix4D, and they had to like create some special like virtual graphics card workaround that was kind of challenging and wasn't particularly helpful, but it did kind of work out in the end. And now I think it's an actual built-in feature of the virtual machine system that we have. All right. Well, listen, I just want to say thank you for the feedback. It's so valuable for us to be able to take your ideas and then think about how to refine this course. And that'll be that'll be really helpful for future iterations that we do for the NERRS as you guys build out more drone capability. But we can also take those lessons in and into our own classrooms. Like the feedback that you're giving me will be really helpful for me when I teach, in person, along with the other online courses that we might offer. So it's super valuable, and I want to like really thank you for taking the time out and engaging because yeah, it is literally how we make things better. So thank you. All right, well, I'm gonna like go on and talk about cool stuff. And the one thing that I wanted to talk about, I know you guys have had a little bit of a experience with lidar, and really just how important lidar can be in a lot of different drone applications. I mean, clearly, there's lots of really good lidar data from coastal surveys. But having this fine scale lidar information from drones is turning out to be pretty valuable. And and the biggest problem with the majority of lidar systems that are out there for drones is that they use red lasers, right? So they use infrared lasers, and that means that we essentially get nothing out of it when it comes to the water. And all of us that are working in these coastal zones would benefit from having kind of a seamless, right, sort of digital terrain model that goes from, especially in these shallow water areas, up onto the land into the vegetation. And most of those tools really haven't existed, but they are starting to emerge. And so there are some really cool topobathymetric lidars that are coming out. For the past 10 years or so, they've been mostly like a single, sort of pulse beam that would give you a profile, but not a scanning system, right? Like what the things that we have now for drones, where that swath, gets scanned, and so having those options are really great. And so now there are actually some drone-based products that give us green scanning laser lidar capabilities. And so this image here kind of gives you this idea, right? You're flying over the water surface, you have a lidar beam that's in the green wavelengths, which means it's not going to get absorbed by the water. It's going to go down. It gives you a hit off the bottom, and using some waveform profiles, you actually are able to see not just the surface of the water, but also the bottom in pretty good detail. For the most part, lidar systems have focused on using infrared, near infrared lasers. One, because they, that those wavelengths are highly reflective in vegetation, which means you get good feedback, right, from your sensor, from the pulse. And the other key thing that's really important, and I hadn't really thought about this until we got an opportunity to test the green lidar or green lidar sampler, is that they're not eye safe. And so the near infrared ones are, you can be around it, you fly over people, and it's fine. These green laser scanners, you actually have to either reduce the amplitude, the energy of the pulses when they're close to the ground, or you have to turn it on when it gets to a certain height when it becomes safe. And of course, there's more PPE. We have, basically sunglasses that would protect you from those kinds of things. But that's been kind of I think was one of the holdbacks, is that they in certain situations can create some safety issues. But I think that a lot of these systems now are at the point where they start off at low power, so they would be okay, and they don't ramp up to full strength until they're high enough that it won't become a problem for you or for animals that are in the scene, that kind of stuff. And some of these green laser scanners are pretty amazing. Some of them can actually sample like bathymetry at more than a Secchi disk depth, right? So when you think about, putting that Secchi disk down and looking for it and seeing it disappear, there are some laser scanners that'll actually get you past that, right? So to be able to send a laser pulse past the surface down to the bottom and back, and give good bathymetry data. Uh, so just to give you a sense of what that looks like for us, right? As we're thinking about, trying to kind of marry the three-dimensional information that we would get from doing structure from motion or typical, red laser LiDAR work on the coastline. You then have this gap, right? And then at that point in time, you would have to fill that in with a separate system that would give you that bathymetry, so some kind of multi-beam echo sounder. So this image shows that, if you were to use a topographic bathymetric LiDAR, you would have this kind of really cool seamless transition from, the vegetated parts of the shoreline down to the beach, and then actually into these coastal shallow waters, and thinking about, being able to start asking questions about sand transport and how does, wave energy affect the movement of sediments around some of the habitats that we work in. Having something that can scan continuously from the land out into the shallow water would be an absolute game changer, right? And so that's, on the left side of this image is that LiDAR bathymetry, DEM, or hillshade, and you can see it goes from, some type of vegetation out into a beach and then into this cool little, often there's this cool little sort of ditch in the nearshore waters, and then it, shallows up again. And it's hard to get echo sounder data in these shallow water areas, right? Like, and there's some folks that work around here that have really cool, they've developed systems using jet skis or other types of tools for working in these shallow waters. But having a green LiDAR might actually be the total game changer for those things. So they're not all just green as well. And sometimes those systems come with a dual laser system where they use a near infrared laser to be able to capture really good information about the water surface. And then they use the green laser to be able to sample in the water column. So here we have that, kind of similar cartoon to the previous page, but with both of those systems working, and then allows you to be able to know the aircraft altitude and your sensor elevation to give, that seamless land part, and then use the green to be able to also sample below the water. And it's pretty complicated. And as you move forward, you'll hear more about how, they using basically different length pulses and looking at the waveforms of those reflections over time, you can understand a lot more about the profile of what, you're sensing, which is that, that middle graph here shows, the amplitude of the received echo is high at the water surface, and then it's, it attenuates, and then, may hit some stuff in the middle, and then, bounces dramatically off the bottom. And adding that into the red laser scanner can be super helpful. So this is coming, and we actually, and I'm not sure if any of you folks actually got to the Drones in the Coastal Zone meeting that we had this year, but one of the vendors actually brought the yellow scan green LiDAR package that they have, and they did some tests here at the Marine Lab. We haven't seen the data yet, but this could be a total game changer for a lot of us, right? To be able to connect all this stuff up. So, all right, so I'm going to stop there before I get into some physical sampling and see if you guys have any questions or comments on that. Maybe be good to know even if you either were aware of those things, or has anybody even been trying to use them? Ah, okay, interesting. And what system did you guys use for that? Is it a like a green laser scanner or is it a single profiler? Oh, from an aircraft, like an occupied aircraft. Ah, okay. Huh, interesting. Yeah, so I wonder if you having, a higher resolution drone sampling system that you might be able to fill in those gaps. Wow. That's super cool. I did not know that. Yeah, I bet you when you think about the point clouds that you generate from the occupied aircraft lidar, uh, the point clouds that you generate from the drone-based lidars are usually like 10 to 50 times denser. And I wonder if that would cure or solve some of those problems where you're not able to actually have build a really continuous map. Yeah, that would be super cool. But again, like what a really cool, you know, that would be a really cool group experiment that we could work with, right? Like, the all of the NERRS would probably benefit from that. And so having some pilot projects where it's like new technology, is this going to be a game changer or not? That'd be a really cool place where you could set it up, maybe have different people try it in different habitats, different conditions, and work together to figure out how to make use of those things. That would be awesome. Yeah, that's right. Maybe that's next. Go talk to Justin about that. He'll be super stoked about that, I'm sure. Yeah, is that it is I would love to hear more about that because it's challenging, right? To be able to make sure that everything's sampled the right way in the right datum, all the technical crap that you have to do to be able to try and match them up. It's a challenge. Yeah. Okay. Well, yeah, I'd love to learn to hear more about how that goes because that's something that we struggle with all the time. And in fact, most of the places that we work, we just don't have access to that bathymetry data. It's just not here. Um, so, any other thoughts about that? All right, let's talk about physical sampling. I think in some of the materials that we introduced to you, there was probably some stuff about blow sampling in there. Was that? I can't remember if that was in one of the videos where we talked about collecting whale snot from a drone. And if not, are you guys familiar with that? Yeah, I think we introduced it in one of the videos, and a lot of the time when we think about using the systems, we're very much in a remote sensing context, right? Like optical, usually passive remote sensing context, LiDAR, more active, maybe some other tools that might be like that. Um, and so a lot of the time the idea of actually physically interacting with equipment or with parts of the environment with drones is not it's not high on people's lists of things. Most people are they're unaware of the capabilities, or they're not sure how it might fit in. And so I wanted to talk a little bit about at least two different sampling systems that might be interesting. And this in the context of being able to work in places that you just don't want to be there, right? It's either your presence can be damaging to the place, or maybe it's dangerous for you to be in that place, or maybe it's just hard or gross. You'd rather not do it. And so one of these applications that we're starting to think about is this really cool remote vegetation sampler, and it's built by a company called Outreach Robotics. and they have two cool systems. One of which is really the kind of the thing that I'm showing you in the picture here, which is essentially this uh, claw and a cutter head, like a pruning cutter head, that are dangled below the drone, and you're able to actually manipulate the cutting head and the grasper in in essentially like 360 degrees, and actually cut samples of vegetation off and bring them back. And so there's lots of really interesting questions that I'm learning more about in terms of plant physiology and understanding about plant health and how they respond, how plants respond to particular challenges. And being able to do physical sampling turns out to be pretty useful. So I actually have a video. I hope I can get that on the screen for you all, and actually show you this thing in action. It's pretty cool. Let's see if I can get my screen up here. Yeah. All right. So you guys can see that. This is on YouTube, and we can post the links for it as well. And this is for the Mamba sampling system. And so this is a little bit more advanced than the thing that's on the screen, the picture that was on the screen, the last slide. But it basically is the same kind of function. But instead of just hanging passively under the drone, this platform actually has brushless motors like drone motors on it, and it allows you to move the payload slung beneath a drone in various directions and use that to sample in challenging places. And in this case, the video shows sampling on these incredibly steep cliff sides where, people just, it's essentially, especially in volcanic places like Hawaii, it's just almost impossible to get to those places because the rock is soft. You can't climb safely with it. And this system is pretty cool to be able to do this kind of work. So, and the as I play this here, you'll see there's a platform that's hung on a wire, and it's literally being held aloft by a drone. The drone is kind of obscured. I'm going to play it now, and hopefully you can see it. It's right here where my cursor is, and now it's going to back away from the side of this cliff, and you can see it's actually being slung under an M300, and it's literally positioned on the side of this cliff. So hopefully you can see it. Here's the platform. It's got that cutter head and grasper on one side, and then you may notice that there's actually propellers that are spinning, and they actually use it to swing the cutting head closer to the cliff top. And you're going to try and sample this weird, funky cliffside plant. Probably never been sampled or tested before. They're able to get their grasper on it. It cuts it off, and then they release it and pull back. And then the aircraft will fly back, bring that down, and you'll be able to sample it. So I actually didn't know that these tools existed until as we start to get to know more people in the Duke Forest. They started talking about being able to try and sample things like cones, or new shoots on the tops of trees. So here you can see the aircraft's just landing, dropped the slung platform, and now it's back down on the ground. So pretty cool setup to be able to think about that kind of physical sampling. And while it's not probably high on the needs for a lot of coastal missions, there are lots of places where we have really cool maritime forest things, and access to them might be challenging. And so that Mamba system might be a little bit overkill, but maybe this Deleuve's system, which is kind of the little brother of the Mamba system, might be it. And so so the goal here is, instead of having it movable, it's just slung below the drone. You're able to come down, sample the tops of those whatever the vegetation that you're interested in, and actually bring it back. So pretty cool, pretty cool thing for the those people who are interested in the vegetation side of things. Uh, you guys, have you guys ever seen anything like that? Any comments or ideas on that? It is pretty cool. Yeah. What was that, John? What were you saying? Yeah, absolutely. This is like one of those things where like get lots of practice piloting, precision piloting will be super helpful. It does have, and I don't know if it actually shows it here. Yeah. So on the controller side of things, it actually there is a camera that's mounted on the actual the on the grabber, like on the extension part that points down to give you that close up view of what the cutter head is doing. But yeah, I agree. Like getting it into the right spot, and that's a practice makes perfect type thing for sure. Definitely challenging. Yeah, so in many cases, I think what they do is they set up the drone controller the controller for the actual cutting head like on a tripod, at the site, and then there'll be a person there, and pilot will be doing things like normal, and then the other person will be providing feedback and then actuating it when they need to do it. Yeah, yeah, lots of spraying now. I think there's, a couple of companies have really amped that up, building relatively big drones and doing pesticides and also fertilizers, spotting, um, treatments, and I guess it's now at the point where the precision that's generated not just by being able to load it on a drone and go to the right spot, but having the drone based remote sensing data to provide the guidance for that. There's things are on par now, right? So that your really high resolution information about health of what you might be looking at can be coupled with really high resolution deployment of whatever that fix is, which is super cool. All right. What's what else do we want to talk about there? Yeah, so we talked about those two things. Ooh, yeah, so the next one I want to talk about was water sampling. And this one I feel like is something that we actually, as coastal researchers, would actually really be able to take advantage of. And there are a couple of systems out there. I have just this one right here. The picture of this one is something called the Nero sampler. And again, thinking about being able to go and collect data in situations where like you don't want to walk into the marsh to mess it up, or maybe, there's been a oil spill, or maybe there's, there are other things that are going on. Maybe you're working in a place where there's an outflow from a water sampling or water treatment plant, or maybe a local lagoon that might be using to dry down waste from maybe some farms or things. Being able to actually get water samples in a safe way in those places really pretty helpful, and maybe particularly important in some disaster response situations, right? Being able to actually, I know, have some colleagues that I work with in Nicholas School, when hurricanes come through, they go out into communities and actually look at sampling floodwater in different places to look at what the problems are, and often they actually have to get exposed to some of these pretty dangerous environments, right? With some of these, the way water is after those disasters. And having a tool like this might actually be a real game changer. So not even just on the science side, but more on like, emergency response might be really cool. And I have a couple of images that show that um, that system, and it looks pretty good. I want to bump back to the web and pop over there. So they actually have some video right on the mast of their website, and here you can see it again. Not surprisingly, sort of slung behind and underneath one of the drones that a lot of us have used to be, super productive. And fly it down. Here we are. They're like working in a marsh system there. That tube can then drag down into the water, and you can slurp up what you need. They make two different versions of it, and one version is a system that will allow you to collect samples into 4 separate bottles, and the other one is just a single sampler. But having a tool like this might actually be incredibly helpful, for certain contexts, be able to do that. It's kind of been it's something that we've wanted to have as a functionality in our lab for a long time. And in fact, I had a research team, at Duke we have the in the engineering program, students have to do a senior design class where they actually build something and then they try and prototype it. And I had an engineering team this year work on a water sampling system for a drone. It was a little bit different. It was actually a physical sampler that would drop essentially a sample tube down, and then it would use gravity to cork it and pull it back up, and you'd be able to collect multiple ones. But this pump system is also really cool, to be able to think about sampling in those places. So another kind of interesting sort of thinking about next steps and how you can think about using the platforms that you use to collect remote sensing data. You might also be able to actually use them to collect other kinds of data from places that, or in situations where you just thought you wouldn't be able to do that before. Has anybody ever used a water sampler in a drone-based system at all? Oh, oh yeah. Yeah, I hadn't even thought about eDNA, but that would be a great way to be able to sample in like hard to get to places, and to be able um, to look at even just like diversity indices and things like that in those places. That'd be amazing. Any other thoughts? All right. Well, last thing I want to talk about is thinking about ways to combine, these kinds of systems, and in particular, thinking about how you might be able to make use of autonomous surface vessels in some of the work that you do. And I would say that for me, in a lot of the work that we do, the some of the most sort of I don't know, like most powerful projects that we've worked on have resulted from this kind of integrated, um, technology approach, right? This kind of integrative ecology where you use a variety of different technologies to be able to, to get at an answer that you couldn't without combining the use of those things. The example that I think is really sort of weighs on my mind a lot, or it's really evident to me, is the when I think about terrestrial ecologists, and you're we may have talked about this before, but you're like, your terrestrial ecologists say you're studying cheetahs on some savanna. You can actually watch the animal, stalk its prey, can chase it, can capture it, kill it, eat it. And you can actually look at all those things and measure how long it takes. And, the animals are accessible because they're visible all the time. And a lot of the things that we work with in marine systems become unavailable very quickly, right? Or they're totally unavailable because they're below the surface of the water and we just can't observe them. And we often can't capture them, or we can't measure things by taking it and removing it from the system the way you can as a terrestrial ecologist. And what that means is that we've, as people that work in ocean systems, we've had to like revert, or we kind of had to kind of focus on data driven remote sensing approaches, right, to kind of approximate what terrestrial ecologists have kind of taken for granted forever. And and so in our case, thinking about combining animal telemetry by putting tags on animals that are diving, and then using echo sounders to visualize their prey fields, and using drones to be able to measure them, to be able to scale their performance that we might get from tag based data, and then even to remote biopsy sampling, right, to collect a sample from an animal. Putting all of those technologies together actually allows us to essentially approximate what terrestrial ecologists have done forever, right? But we just do it with sensors in a very data-driven way. And in fact, I would say that at this point now, because we've been forced into having to do that, to innovate, right, to be able to do these things, our techniques are more data-driven and now are actually being leveraged by terrestrial ecologists to be able to up their game, right? And it's cool to think about how necessity has forced us into innovation, and now we're doing things that that you just like we're not able to do because we work on the ocean. And so one of the things that I think would be super valuable is some of the use of these autonomous surface vessels, and they don't have to be big; they can be quite small, and they can be quite affordable. And I have a video in a minute that I'll show you of a deployment of a surface vessel that we have here, and its use in being able to map out water quality around some stormwater outflows in the town of Beaufort to try and understand whether or not there was leakage, right? That we were having some contamination from those things. But these are great. They're very small. They're pretty affordable. Some of you guys might actually use them in these contexts already. You can stick a bunch of different kinds of sensors on them, right? So you can look at any kind of biogeochemistry stuff you want to do, whether it's physical, chemical oceanography, or whether you want to look at fluorescence or turbidity, or and also even do water sampling from these tools. Much actually simpler when you're actually on the water. And also being able to put things like side scan sonar or other bathymetric tools on board of them, and these things are everywhere now, right? And I mean, you've seen maybe some of this even coming out of Ukraine, right? With them using these autonomous boats to try and actually attack enemy vessels, and that all that technology is actually the same as the autopilot and the motors that you use in drones, right? So we're able to build autonomous surface vessels that use a Pixhawk autopilot and brushless motors, and essentially use Mission Planner, the same tools that or Q ground control tools that you would use for some drones, and actually map out autonomous missions of these tools. So the one that I have here, this is an expensive system that's made commercially, but there are lots of other ones that are helpful that we've actually built ourselves. And so I'm going to show you this. This is like a quick video that that kind of shows the deployment of this vessel. For context, this is a little wooden boat. It was actually built by the Maritime Museum Boat Builders group here in Beaufort. And it has an autopilot that's built into a pelican case. You can just kind of see that. That blue instrument on the bow of it is actually a YSI water sampling system that's continually sampling temperature, salinity, turbidity, and then this is essentially programmed out. At the same time, this boat has a sonar system on it, and it can actually essentially do the same kind of mission profiles that we would do with an aerial drone, but be sampling parameters from surface waters. So you don't really need to hear the sound. So turn that down. But I'm going to play this now. So here's this is like during the times of COVID. So we were one of the labs that got back to working pretty quickly, and so on board this little vessel is our science sampling stuff, and then there's also this camera, and so here this is kind of giving you the combined view of that. So we just dropped it off the dock, and you can see the map of the vessel. You get the live video of the drone, And you can see off it goes and is starting a mapping mission. Like this up here, it actually comes up towards a boat with some folks that are fishing, and I imagine they were just like, "What is that?" Like he didn't even notice it was there. So it just hit the waypoint. Now it's going to come back. And I think he had to actually take over manual control here so it didn't run into this guy. He's like kind of looking at it. He's like, "What is that?" And around it goes. And then back on track. And so we've actually used this system to be able to map out water quality around one of the Duke Marine Labs oyster farm, and then actually to collect a lot of really great water quality in Gallons Channel in these places that are around the town of Beaufort to look for signals from of water quality that might be coming from septic tanks that are leaking or from stormwater outfalls in those places or leakages in the sewer system. Yeah, and then this is what that looks like, um, you know, on as it approaches back to shore. So cool system, side scan, sonar, bathymetry, and biogeochemistry sampled all at the same time. And really simple low cost technology. Like the majority of the cost of this is in the sensors. The boat itself probably cost, I don't know, $150 to build and spec it out. So I'll stop that there. See what you guys have to say about our kind of Mad Max little boat system. Anybody out there using these kinds of tools, autonomous surface vessels, to be able to do combined sampling in their environments? Oh yeah, yeah, that's a great solution. Yeah. Yeah, you guys can borrow it anytime you want. We're the next iteration of stuff that we're building out on this is to actually do and this guys maybe you guys will laugh about this, but to do alligator eye shine surveys. So I have an undergrad student who's building a computer vision system to automatically detect and count alligator eye shine in reflected infrared light, and we're going to program it to kind of like we're going to take it to some of those ditches up by Alligator River, and just program it to at night to just cruise down uh, these these ditches and actually count up alligator signs, which would be pretty fun to be able to set up. A couple of lakes up here by Cherry Point they were surveyed maybe 20 years ago, and there were 100 alligators in one of these lakes back then. So I'm wondering how many there might be in there now. And it's way better to have the robot do it. If you take a student in the field and they get eaten by an alligator, it's a bad thing. It does not. No, that's right. Yeah. Yeah, so no FAA because they aren't, governing and so really it's Coast Guard stuff. And there aren't a lot of rules about boats that aren't like occupied, right? And so this is something that I think in many ways it could probably be simpler. Um, and I think in many ways it's lower risk. Um, but these are going to be tools that are going to be used to be able to monitor ports. All of that stuff is coming soon. And these more advanced systems are going to be, you guys have probably seen some of those surfboards that once they get up to speed, they hydrofoil up and they sit on a blade, that's a hydrofoiling. These next set of autonomous boats are going to have high speed capabilities that'll be foils like that, but they'll sit at the surface like a surfboard and putter around kind of like this one, right, over time. And these are going to be used in a lot of different contexts. Might not be great for us working in these shallow waters, but this is technology that's all coming, and will be, thinking over the next 5 or 10 years, become increasingly available to us to be able to do these things. Right. Yeah, exactly. Yeah, and what'll happen is some knucklehead will do something silly, and then that will make it difficult for all the rest of us who are, actually doing things, trying to do things the right way. That's right. Stay tuned. Stay tuned for the problem child, and then the cascading effects on us. So yeah, yeah. Any other thoughts? I really like. I kind of feel like where I would really like us to be is thinking about the places that we're working as being like, these like, especially the NERRS. Like I have this like long term vision that the Rachel Carson Reserve here is instrumented with like, networked water level loggers, and that we can have drones that are automatically flying over, um, and we have autonomous service vehicles that could be able to go and sample in places that we want. And I feel like the NERS is a really great setup, right? It's, you guys are focused on being able to support research. You have great questions, and you also have limited resources, and so it's a really great place to think about how we could leverage these kinds of tools to be able to build a more holistic understanding of how things are changing in these environments. Um, so I'm hoping that, as we move down the road, and my goal is to work here with our ears to be able to build that out into a really, nice networked system that allows us to leverage these tools to be able to answer questions faster. All right. Well, I think actually that's all that I have for y'all tonight. We're at a 8:21, so it's been kind of a long one, and hopefully you found it interesting. And I just want to say, yeah, thanks again. Thanks for all your engagement. I hope that you guys enjoyed it. It's really nice working with you all. I love working with Justin. It's really nice to be able to think about this collaboration, and again, thank you very much for the feedback today. It's super helpful for us. So yeah, I guess it's time to say goodbye. I hope you guys had a good time, and I hope everything goes well in the field as you get into your summers. And make sure you give us some more feedback, and always reach out if you have questions. We're here and excited about working with you all. So thanks, and yeah, enjoy the rest of your evenings. And if there's no other questions, then I'll send you guys all out back home, and you can get on with doing whatever you're gonna do. Maybe watching a hockey game or something. I don't know. Yeah, my my pleasure. Absolutely. Yeah. Okay. Bye for now.